I'm Charleston Malkemus from Capital One. Talk a little bit about developing an AI-first strategy. And this is really a little bit more from the lens of business product leaders, setting them up for success to be able to lead with AI, but also be able to maximize the investments that they would make in intelligent solutions. So, 2020 has clearly become it's a breakout year for artificial intelligence. ChatGPT 3.5 was released last November. Just in many of your business as well, a massive action for it's very reminiscent of over 50 years when Steve Jobs released the iPhone. And the iPhone ushered in a huge wave of mobile adoption. But it was not nearly complete until we had the work of Luke's mobile-first strategy, as well as other thought leaders in the space, who collectively mobilized us as an industry to start designing and developing our products with a mobile-first mindset. And some of the lessons that they imparted on us was, this was how we were going to capitalize on this market opportunity. This is how we meet the demands of shifting customer expectations. And some of the points that they really focused on was working within the constraints of the mobile platform. So back then, it was small screen sizes, limited bandwidth. I mean, obviously, they weren't in the world, but they also showed us that we needed to really focus on what matters most and simplify our experiences, because that was going to be how we would uniquely take advantage of that platform and its capabilities. So if we were to take some of these lessons and apply it to developing an AI-first strategy in our organizations, what are some of the things we might see? Well, first, many of the trends are the same. We're seeing right now massive market opportunity, shifting expectations, and ultimately a new competitive landscape. So if we were to leverage some of those lessons, that playbook, how might we prepare ourselves to capitalize off of this next wave of innovation? Well, again, we might look at what are the unique constraints we need to operate in with an AI, ML world. On what investments really might provide the greatest strategic advantage for our company and for our businesses. And we might rethink our products now with an AI-first mindset, and what would that even mean, and what would that look like? Today, I'm going to cover two key imperatives I believe are critical to be successful with AI. Example of what it would look like in taking a simple service and making it an intelligent service. So the first, data a discipline. If you haven't already, I would strongly encourage you to make data a discipline. Teams working on intelligent initiatives today, most of their time tackling data problems rather than refining, optimizing, or testing their models. Now, for me, this is a huge call to action because that's where the leverage is. Accelerate our velocity, deliver value to business and our spending more time on building intelligent solutions rather than being in the trenches with data is unlock a lot more value. It really all begins with your station. Having a chief data officer or your practice and operation to tackle the complex challenges associated with is certainly going to set you up for success. Because when we think about this, which you're hearing a lot about today, these security, privacy, bias, they're only going to continue to compound in this very data-intensive AI world. But for the purposes of today, we're going to focus a little bit more on the data products and the investments we may need to make to be able to start to drive the enrichment process that leads to intelligent apps. So here's an example of 10 different disciplines they're dealing with, and you can see they're grouped thematically around some problem statements you may be facing, whether that's data access, data control, where did that data come from, who can use that data, how can they use that data, why they can use that data, data quality, is it valid, is it fresh, Have we associated the right identifiers and its metadata? And then how do we develop data products? How are we managing versioning those data products and the changes associated with them? Because those changes will have residual impacts. And then ultimately, how do we enrich that data? So if we move into establishing a data foundation, one of the first things to think about is if you're operating in a microservice environment, right? This wouldn't apply to necessarily everyone, but if you're operating in a microservice environment, two industry recommendations is start laying down your streaming and archival services, because those two capabilities quickly become the backbone for building both operational and training data services. And those are the essential ingredients to being able to rapidly build, deploy, and govern intelligence solutions. And they're really what you're going to need to be able to power the enrichment process. And when I talk about the enrichment process, I'm really thinking about these 5 different stages that you need to be able to take raw data and take it all the way through to produce an intelligent outcome. Now, we showed here a little bit about ingesting data from various sources, but it's also important to think about how you're landing that data in those operational and training environments, and are you organizing it and storing it in a technology that's appropriate to your ML strategy. When you're choosing your ML strategy as part of your design, there's an inherent benefit in leveraging different types of technologies. That could be like a time series database, that could be a graph database, it could be a wide columnar database. That has a fundamental benefit in the overall success of your project and initiative. And then also, as you move into the later stages of enrichment, you have all the different types of enrichment you can do, whether it's through simple calculations, model scores, model predictions, or when appropriate, even decisions through the policy and rules that may drive your business. You have to really think about it completely end to end. It's not just throwing one model out there that's going to get you the results you might expect. So that brings me to my second key imperative, and that's build prime intelligence. So I think you've seen a lot today, or at least I have in the talks I've participated about. You are seeing a lot more results from highly specialized models. And conceptually, this is no different than what we're seeing emerge in generative AI with foundation models. But it's important to know, for the last number of years, we've been operating in an era where the mandate was bigger is better. Certainly in the conversational AI space, it's been about the greater number of parameters we can use, the greater number of results we can see. But the story now that's quietly emerging through some studies is that smaller, specialized models are starting to outperform their bigger brothers. And that's at the heart of the concept of prime intelligence. Because it's really nothing more than a building block approach to developing sophisticated intelligence, while applying some of the lessons we've learned from microservices. We've been on a journey with microservices and the architecture that it represents for our ecosystems for over a decade. And if you look at some of those core principles, whether it's designing them to have a single responsibility, discrete business boundaries, clean interfaces, automated processes, designing them for failure, I would argue that all of these could be translated into how we should be designing and developing our models. Right? There's no point in us reinventing the wheel. We have a lot of history and technology to leverage to be able to take advantage of where we're going. And certainly those top two, when you think about a model answering one primitive question and then being able to ensemble multiple models together to answer more complex questions, you can start to generate very powerful results. And this gets a little bit to the heart of the relationship between models and microservices, because models don't take actions. They depend on microservices to be able to do that. And you can see here that they really solve two very different types of problems. Whereas a microservice might take a specific action, solving for a business capability, a model is trying to produce a specific answer to solve for a business question. It might be hard to see there at the bottom, but if you take a simple example, like a content service, many of you may have a CMS or a digital asset management service. Well, a simple API action that microservice would provide is get content with an explicit ID. But if you start to think about how you would make that an intelligent service, you could argue that a a model could provide you the answer as to which content that microservice should get, based on a whole number of factors that it's been trained with. Well, if you think about that interaction now, that fundamentally changes the design pattern and how those services are working together and communicating. And I'm going to walk you through a little bit of an example later. So this also provokes the thought about designing our models with questions in mind, right? So if I were to decompose questions into their discrete components, so then I could build them back up to answer more complex questions. And I'll go through a little example here, which almost every business faces. Which product should I market to a customer? Seemingly very simple, but if any one of you walked up and asked me that question, you better believe there's going to be a whole number of other questions that I'm probably going to need to answer and get from you to be able to get to that conclusion. You know, and we can target some specific elements in that question. You know, what's the product and what benefits does it offer? Who's the customer? What are their needs? Where do they live? How would I market one to the other? All of those are foundational for us to be able to arrive at an answer to that bigger question. So that inherently becomes the challenge that we're dealing with when we're designing our solutions, our intelligent solutions. So this also brings up on a principle of design your questions to be very specific. What I have seen and experienced is we have a tendency to be very vague with our questions, and that generally leads to poor results and poor returns on that investment. Next best action is a very commonly used term, but without the right context, it is relatively meaningless. Whereas specific questions generally produce very highly accurate results, and the benefit that comes from that is you can now build upon that to get more complex answers. You know, so one of the recommendations I often make is, you know, we should be asking ourselves more, what's the next best question we need to answer to get to where we want to go? So, taking those two key imperatives, make data a discipline, build prime intelligence, we're now going to apply them to designing an intelligent capability. And the first thing that I would recommend when you go down that process is make sure you're doing a thorough evaluation and analysis, so you truly understand the true costs and outcomes you need to achieve to make sure you're going to get the results you want. Because there is a threshold. Models are never 100% accurate. And you have to evaluate at what level of even accuracy you will need for that to produce the intended result for your customer or for your business. So 5 criteria in doing that evaluation. Think about the goal. You gotta have a very clear goal up front on what you're trying to achieve, and really ask yourself, is this where the strategic leverage is? And scrutinize whether the investment's gonna be worth it. I would hold a really high bar. You got to think about those interfaces like we were just showing earlier between, you know, microservice models and operating in a system design. How are they all working together? Controls. Are there any controls that we need to plan for up front? You know, guardrails or limitations that we want to put in place. What's going to be our training strategy? How are we thinking about training that model up front as part of the initial stage, and then as an ongoing basis with reinforcement learning? So, you know, we had today in one of the general sessions, the RLEF, right? So like, if you're gonna do reinforcement learning and have expert feedback, you need to plan ahead. What's all the tooling and capabilities you would need to be able to support that? Because it's more than 0. And then testing, like what's your testing and release strategy? And this one I've seen in a lot of initiatives often get overlooked, and it's an important one, so you'll see that in a second here with this example. So I'm going to go through one example, taking a very common, simple microservice. So this is just a messaging service. Think like AWS SNS or Google's GCM. You know, multiple APIs, send this messaging service requests. The messaging service leverages a content system, a customer service, to be able to compose a message and then send it out through multiple channels. Right? So very basic. But we're going to take a look at what it would look like to turn this into an intelligent service. So the first question I like to ask is, what is the unique question that this microservice is positioned to answer better than any other microservice? So there could be many answers to that. My argument is where and when. So where I would want to send that message, meaning which channel, when I would want to send that message, meaning which time or day. And that's based on the data that it would generate or have access to. So with those questions in mind, what would be an appropriate goal then for this investment in intelligence? I would argue if I can optimize the delivery of where and when a message is being sent, I should start to see an increase in open rates. I would also want to think about the complexity that's introduced in this problem statement. So currently, many of us are living in a world where customer preferences are rapidly changing. Channels are emerging almost every other day. We had Twitter turn into X over the last couple of weeks. Threads came out, and that makes it very challenging for organizations to develop a comm strategy around where best to communicate with their customers. This might be a good example of where a model is uniquely positioned to do that better for us. But it also brings in another element into scope, that the model would need to be able to adapt dynamically to new criteria, meaning programmatically it could adjust to a new channel being introduced in the environment. So you would want to do some sort of testing and optimizing strategy as part of its design. So now I ask, what would need to change? When we think about that being the goal, we kind of have the outline for what our intelligent initiative is going to be here. And I would honestly recommend there's probably 6 different capabilities here that we need to think about redesigning that would be part of the true cost of getting the outcome we would expect. And I'm going to go through each one here. So first, we might take a look at the interfaces between the APIs and the messaging service. As opposed to an old API spec that would give us the who, what, where, and when, we might actually want to update that now and remove the where and when. There's no reason to say that anymore. We're depending on the model to make that decision for us. But we might also want to add in something like the message type, which would give us a little indicator as to the why, because that might become an important parameter to optimize around. Right? I want to send marketing messages different than fraud messages and different than servicing messages. Next, we might want to think about creating a library of multi-channel content. Now, this is an important one because it actually limits the ability for the model to be able to optimize across channels. If it doesn't have content to send out on Twitter, well, X, or Threads, or some other channel, then it can honestly optimize for it. But this also then prompts the point that that's a massive investment. Because now you're saying for every message, I need to have content for every channel that I want to be in for this to be able to optimize across all those channels. And in many organizations today, your comm strategy may only be 1 or 2 channels per message. So you have to now pair that investment with what you think your expected returns are going to be. Because otherwise, it's just going to be limited out of the gate. This also makes us rethink the content library, as opposed to it just being an independent, discrete set of assets, content 1, content 2, content 3. You now might want to think about organizing the content around messaging type to help support optimization, and then also setting it against a set of channel-specific assets for each type of content. Third, if you want to plan your controls from the beginning, this introduces 2 new capabilities. A rules service that might be able to manage suppression lists and regulations, which in the messaging world there's a lot. TCPA, Do Not Call, Can't Spam Act, and then a scheduler to be able to customize delivery times and manage retries. We also need to think about our training strategy. So here, preparing for a continuous feedback loop, this illuminates a little bit of an unsupervised learning strategy. And you can see we're starting to reap some of the benefits from our data investments because I can now leverage that streaming service to quickly aggregate a historical view of all outbound messages and their related performance. And that would directly optimize the model. So that's almost a foundational need that I'm going to require moving forward with this project. But we also need to think about enabling human supervision and training, right? That's the EL in that REL statement, where humans and experts may need to be able to view the performance of what's happening in the system and make corrections, because it's never going to be 100%. And we also might need to be able to fine-tune the parameters of the model based off of changes. What if we eventually wanted to upgrade it to a design where now it's optimizing delivery for a multi-message campaign? Right? That might change the actual characteristics of how it's going to deliver those messages. So you're introducing now 2 new requirements with a user interface and adjustments to the model. This model now need to have its parameters configurable. And then lastly, we have developer release and testing strategy. If we're going to run multiple models in production, either because we're releasing a new version of it, which almost anyone who's building a model is going to have to do that, you need to think about your deployment design. That's a whole other set of investments you got to make. You also might want to think about testing totally different model types and challenging them against your current existing models. So the one inherent benefit you get from this is that you also can leverage it to reduce deployment risk. You can now use tactics like a blue, green, or canary deployment. If you have models in your organization that drive tremendous value for your customers and your business, there's a huge amount of risk when you're actually changing them out, retrofitting them and redeploying them. So you can see here how the costs have really started to add up, right? The investments here have started to add up. What began as a simple microservice, we now have, which might have just had an API and a scheduler, we now have a user interface, we have a rule service, we have a load balancer, we're running multiple models, we built out a whole historical data set. That's a lot that you need to think about in terms of achieving the true benefits of this project. So we covered 2 key imperatives, making data a discipline, because that's what's going to power your intelligence, and thinking about your intelligent initiatives in terms of questions and breaking them down into their discrete form, their primitive form. And then lastly, when you're building out intelligent capabilities, applying it through a lens of how does that look, how does that change the fundamental simple microservice with an AI-first mindset. Thank you. I'm Charleston Malkemus. Again, if you want to follow me after this or on LinkedIn, more than happy to connect.